Hello everyone, in this video I'm going to be solving an optimization problem that involves a conical funnel. So I wrote the equation down here. It says a conical a funnel has a base diameter of 4 centimeters and a height of 5 centimeters. The funnel is initially full, but water is draining at a constant rate of 2 centimeters per second. How fast is the water level falling when the water is 2.5 centimeters high? So with what we have here, we can find for what it's asking, right? So what it's asking is like the rate of the water level changing when h is equal to 2.5, when h is equal to the height. The rate of the height would be dh divided by dt, and we're trying to find for the dh divided by dt when h is equal to 2.5, which is 5 divided by 2 centimeters, and this is what we're trying to find for. Also, we can find for another thing that we can use for when we're solving for this problem. Here it says the water is draining at a constant rate of 2 centimeters per second. And that tells us that the volume inside the conical funnel is draining at a constant rate of 2 centimeters per second. But since it is draining and not like flowing into the funnel, it's going to be -2. Okay, and let's make a drawing to represent this problem. We have a conical funnel that looks something like this, that has a diameter of 4, which means that the radius is 2. So the radius is 2 centimeters, and the height is 5 centimeters. Okay. The way we're going to solve for this problem is by using the volume of the cone. The formula for the volume of the cone is equal to 1 divided by 3 times pi r squared times h. Okay, so obviously we're gonna want to keep h as our variable, so that when we take derivative on both sides, then we'll have dh divided by dt on this side, and we want dh divided by dt since that's what we're trying to solve for. So that means that we want to get rid of the r, since that's obviously not going to be our variable, like I said. So we're going to change the radius so that we would have it in terms of h. r divided by h is equal to, the radius is 2, divided by the height, which is 5. Multiply h on both sides, and we have r is equal to 2 divided by 5 times h. We're just going to substitute this into our radius here. And after we do that, we'll have 1 divided by 3 times pi times, we're going to have to square our radius, which is 2 divided by 5 times h, which will be 4 divided by 25 times h squared times h. Since we have h squared times h, we can just change that to h to the power of 3, since we added the exponents together. And now we're going to take derivative on both sides. We'll have dv is equal to, the 3 comes down, so we'll have pi times 4 divided by 25 left, and also h to the power of 2 times dh. Divide dt on both sides, and we have dv divided by dt is equal to pi times 4 divided by 25 times h to the power of 2 times dh divided by dt. Okay, so we're trying to find for the rate of the height, dh divided by dt. So let's solve for dh divided by dt. This is equal to But before I solve for dh divided by dt, I'll just substitute the dv divided by dt, which is -2. So if we solve for dh divided by dt now, we'll have -2 divided by this whole thing. And so I'll just write it like this. We're trying to solve for dh divided by dt when h is equal to 5 divided by 2. So let's just substitute that in for h. We have to square the h, which means that we'll have 25 divided by 4. And as you can see, we can cancel out these two fractions. And the only thing that we'll have left is -2 divided by pi. And now we found our rate of the height when h is equal to 5 divided by 2. Thank you for watching, everyone. I hope everyone watched this video and understood my explanation. So thank you for watching. Bye.